Moin, this is either going to save me liters of chemicals or completely destroy this print. This 3D print is too big to electroplate normally, so instead of using a giant tank, I'm trying to plate only one section at a time while the whole part slowly rotates. To make that possible, I built this custom rotating machine and designed my own PCB to control the speed. Now we're about to find out if this can create an even copper layer or if I just built the most complicated way to ruin a 3D print. But it should work, right? Right? I usually use PLA for my electroplating projects, and I usually use my Bamboo Lab H2S FDM printer. But that's not really the important part. What matters way more is this: don't glue it together with just a thin layer of super glue like I'm doing here. Seal it properly with a nice thick layer. Now I'm going to sand everything down really well first. Later the conductive layer will go on top. And from this point on, I'm working with PPE at the latest. Lab coat, respirator, gloves and eye protection. That stuff is important. Your health is not worth gambling with. Okay, first we need a plating tank. I found something here, but it doesn't really work properly. So I designed one in CAD and ordered custom cut acrylic panels for it. This usually works really well because you can just glue everything together with this extremely smelly acrylic adhesive. So I held all the pieces in place, and yeah, if there's one thing I'm absolutely not good at, it's working with this glue that's supposedly supposed to wick itself perfectly into the gaps. Somehow I managed to make it work, and then I had to cure it with a UV light. In the end, with surprisingly little effort, I actually ended up with a pretty nice plating tank. This electrolyte will go in here later, but not yet. So I need to build a new rotary jig. My idea was to make something like a spoked wheel. The spokes are made out of conductive copper and connected to the outer rim. Did anyone actually notice the prop, by the way? Then in the center I insert a copper pipe, and the current should be able to flow out through the middle. The copper pipe was too long, so I wanted to short it with a saw, but honestly that felt kind of stupid. I knew I had a pipe cutter somewhere. There it is. These things are so satisfying to use. So somehow the pipe goes in here. This is basically how I imagine it. Now it just needs to rotate. For that I had to design a motor mount in CAD. This is what it looked like in Fusion 360. It's basically just a height adjustable stepper motor holder. The stepper motor goes in at the top nicely without any cooling, which is not ideal. At the bottom I made the base larger so the whole thing doesn't tip over. Then it holds the wheel and is supposed to rotate it. I printed it in ABS, no, not PLA, and then I wanted to glue it together nicely with glue this time, but yeah, it's ABS. Fail. Whatever. So now I insert the pipe motor, then put in the plating wheel, and this is how it sits above the electrolyte tank. Honestly, that's pretty nice. But now I still had to build a controller for the stepper motor. I wanted a solution that could control both of my old rotary jig and the new stepper motor. As simple as possible, as straightforward as possible. For that, I needed a few different components, like a buck converter and an OLED display. The whole thing is based on an ESP32. For the stepper, I used a big TreeTech 3D printer stepper driver. I programmed the ESP with ESPHome inside Home Assistant, so I can also automate and monitor the whole thing later. Once everything was working, I created a schematic in EasyEDA. And when I believed it was at least somewhat correct, I moved on to the PCB routing. I wanted a cool shape that I could later put into a nice enclosure, so I went with this design. A few days later the PCB arrived, and since I always try to properly mention my YouTube members, I added the names of the members at that point in time directly onto the PCB. So thank you all so much for your support. Alright, now I need to get all these components properly onto the board. Soldering is honestly one of the most relaxing things I know. I just love it. What I don't love is desoldering, which is why I used as many JST connectors as possible. I had never crimped before, but in my opinion, it's just as satisfying as soldering. I might need to think about getting a new hobby. The connectors are ready, everything is ready, now I just need an enclosure. I had already designed and printed that beforehand. The enclosure has a slightly unusual layout for the inputs and outputs, but the PCB fits perfectly inside. After a lot of fiddling, I got the cables installed, and then it was time to deal with threaded inserts. They go into posts that are way too thin, and then I somehow try to straighten them out using the CNC Kitchen heat set insert tool. So screw everything together, put in the servo and the stepper, connect 24 volts and boot it up. I have this rotary encoder here, and with that I can basically control everything. Speed, rotation direction, start, stop, on, off. And the OLED shows what's currently going on. So yeah, this was a lot of fun. I'm thinking about cleaning the whole project up and making everything available on GitHub. So let's connect it to the Rotojig, and yeah, not this one. That works exactly the way I want it.
Oh, of course, why not? I'll think, you bask. You're the star, I'm just the brain.
Must be exhausting doing nothing.
Before I even start coating the 3D print with copper, I first need to get it really smooth and even. For me, the best way to do that is by treating the whole thing with automotive filler. Again and again and again. It's an endless torture of multiple layers with sanding in between every single one. Once that's finally done, you can make the surface conductive either with copper paint or graphite paint. Conveniently, I can now use the Rotojig as a painting helper. I spray it on with the airbrush at 2.5 bar. Once it's fully dried, I stabilized the copper rod and simply placed the whole part over the basin. Then I wrapped the piece with thin copper wire to increase the contact area. The new tank also needs anodes. For that, I simply cut some copper sheets and bend them into shape. Then I hang them at the front and the back of the tank. The idea is that the 3D print is always positioned between the anodes for a certain amount of time while it gets plated. Now the acidic copper electrolyte goes in. I connect the positive terminal of the power supply to the anodes. The 3D print is connected as the cathode through a sliding contact on the copper rod. The current has to be kept constant here, which means the power supply regulates the voltage. The current density needs to be set higher, 2 amps per square decimeter. And with this setup, the plating time is also roughly 4 times longer. So I let it rotate for a while and waited. I noticed that it was wobbling a bit, so I printed these 2 stabilizers. Now it runs much better. After 20 hours, I took it out. Now it's time to polish this thing. And yes, this is another great way to completely lose track of time. The fun starts with a sanding sponge and eventually ends with polishing paste in different grids. 2 audiobooks later, I finally had it polished enough so I could move on to the next step. Next, I wanted to apply 2 more precious metals, Palladium and gold. I'm doing both with pen plating. A graphite rod acts as the anode and a cotton swab soaked with electrolyte holds the plating solution. Apart from that, everything works the same way. Using circular motions, I first plated Palladium onto the print. That worked reasonably well. And now comes the painful part, carefully masking everything with tape. The exposed areas can then be gold plated, and that works the same way. In general, I collect all chemical waste and dispose it separately at recycling stations. You know, responsibility and all of that. Even worse than the masking was using a tiny brush and ink to paint a small bevel black. But hey, at least it trains your fine motor skills. But it still doesn't end there. The prop also has these little set-in stones. Great. So I simply printed transparent gems with my resin printer, then used transparent acrylic paint and glue to stick them onto aluminum tape. Once everything was dry, I could just peel them off and attach them. Looks pretty decent, actually. It's aluminium. Oh, I get it. So that's it, I'm done. Here it is, the electroplated 3D printed prop. So, does partial plating on a print works? Yes. Is it easy? No. Would I electroplate a life-size Stargate next? Absolutely not. The next video is already in the works, so subscribe here if you want to see it. Tschüss!